Good morning, hello. I know I was a little bit late getting started, but I was setting up a few things in preparation for this stream. Plus, the electricity went out sometime early this morning, which reset my alarm too, which wasn't the best. But I'm still here. Got internet, got electricity, and I think I figured out what we need to do to get things working. I was able to do a successful test in an isolated hash map and vector, and sort of like created a system and components and sort of like figured all that out. And so I want to go through that today. So the first thing that we're going to do is I want to sort of like show off like what are all the different things that we need to do. So I'm going to use this tool called Freehand, which is by Envision. It is a great whiteboarding tool. I've been actually using it a lot with my work as sort of a collaborative design whiteboard, and I figured we can, use it here too. So the idea here is I can get my pen and I can just draw whatever I want. So perfect. I don't really have an undo as one of those. So, all right. So we have a couple choices when it comes to our Rust data structure here. And let's imagine we haven't done anything. And I was starting from scratch. How do I want to store this data? Well, we know we have these entities that have a whole bunch of like unique data to them. We want to store those in some kind of row, some kind of vectors that are all next to each other in memory. So we know we want like something like locations, and then it'll be some data structure. It doesn't really matter what, but that might be something like 5, 7. 2, 3, and so on. So let's say we had 2 items here. And then we also know that we need velocities for our flocking simulation, so our bird. So if we think about what the flocking simulation is going to look like, in that lovely straight square. Hello, Chantilly. Good morning. So we might have I know, like, I got complaints from my wife that that I'm using circles and they're boring. See what? I don't know eraser. What are you? You're a line probably. Let's do like little triangles, little green triangles. So if I want something like this, we want birds. And the idea here, if I do 3, it's going to be a lot easier for us to sort of do the calculate, see what we need to do here. So in one part, we need birds to be updating their positions, right? So we know we need some kind of system. So we'll have, we'll just do it here, system. Oh, I need to not like press a button or something. Okay, so systems. We know that we need just the update location. So we know we need to do that. Update locations is going to be reading velocities and writing to locations. And that's all that's going to be. So we need, at some point in time, we need to be able to read from, we need to be able to write to this. So get like a mutable reference to like this list. So if I come back to here, we can go, all right, so we're also going to have velocities and you're going to be something very similar. You're going to be maybe like a 1.2 and 3.1, 2.7, 3.9, something like that, let's say. So I need to be able to read from these and write to them. Okay. What other things do we need to do as a part of a flocking simulation? We need to avoid the walls. So we need avoid walls. So what does that mean? We need to read locations and write velocities. Now, I'm ignoring the resources section because whatever I do for us, like whatever I do here storage-wise, I think it's going to work exactly the same for resources. So I'm not going to do anything weird like RC RefCell the world itself, because that's going to cause problems. And we'll get into those a little bit later. Instead, what I'm going to do is probably RC RefCell the resources themselves, but we'll get to that in a little bit. So update location, avoid the walls. Let's say we do have resources. We want to read the arena size. Okay. What else? What other systems do we have here? We have we need to draw. So in draw, we need to read. Let's see. We need to read the mesh, and we need to read locations. Okay, that's easy enough. What else do we have? Oh, it's the wrong color, but sorry about that. Okay. We also need to like move towards each other. So for each bird slash like entity in the simulation, it's going to be attracted towards the center of all like whatever it can see. So there's going to be I actually think that I can do this. There's going to be like a circle around each of the entities. It's going to look through them and say, ooh, wherever all the entities are that I can see, I want to steer near the center spot, which would be right here. So to do that, I need all of the, so what would this be? Is green? This is steer towards each other. That is, do that back to this orange again. Okay, so that's, we need our locations. We're not going to update them. So read locations. I need to write to the velocities, because I'm just going to add that. Now, maybe I don't have velocities. Maybe I need an acceleration. Maybe I don't change the velocity. Maybe I change the acceleration. However, acceleration is really just sort of like changing a bunch of things, then it gets added to velocity once at the end. So that would actually make a lot of sense. I think that's what we need to do. So we need an accelerations. So think about that. When we're updating our location, I only need the velocities. When we avoid the walls, I believe I only need the velocities, but I could also do the accelerations. Sort of like a big push back, like away from it. Probably in this case, this is not going to be velocities, but rather I need to write to accelerations. Okay, then I have the arena size. We're reading that. Okay, that's fine. Draw, we just need the mesh and locations. Steer towards each other. Okay, we need the locations. And again, this is going to be the accelerations. So we're going to determine, okay, we need the accelerations. We need to maybe like read the size, like read like the size. So everybody's going to be the same size. So that way we know like where the center is. I'm not exactly sure. I guess we could think of here. You know what? We actually don't need a size. Let's think about this. If we have a center position for each of these, and they're all within this radius, and we calculate out that this center point between all of these is right here, then I just take this vector that we have, we take our vector, and we move towards each other. So really, I don't need the size. I just need to know where everybody is near me. So size of this radius is really what we care about. So like vision size. So like the vision radius. What else do we need? Okay, so we steer towards each other. We're also gonna steer towards direction. So at the same time, we're also looking at all of these. We're gonna be saying, well, we want to steer towards wherever we're heading. Like it looks like we're heading in this direction, so we want to steer towards that. So okay, what does that mean? We need to read our location so we can calculate this. So we need to read our location. We need to read our vision radius. And we need to write towards acceleration. Yeah. Okay. So what else do we need to do? We need to steer away from each other. And I think that's going to be the last steer. Still. Steer away from each other. So collision, like detect collision. So that's going to be, where am I? How big am I? And where is everybody else? And let me avoid them by changing my acceleration. Okay, so that's really going to be the same thing here. I need to know, except instead of vision radius, it's going to be size, like how big I am, like my size. But again, everybody's the same size. That's going to be a that's going to be some kind of resource probably, because it's only one, and that's fine. Okay, so it's not too terribly difficult. It's just read one thing, write one thing. We also need to so we have draw. We need to update our, it's like we need to update the velocity with the acceleration. So we need to read the acceleration. We need to write the accelerations and write to the velocities. So that way we can reset. And then we also need to, well, we have update location. What else would we care about here in this case? I don't know if there's anything. I think that might be it all. And of course we can play around with it later, but something that I'm seeing here, the pattern is I only need one of each thing. I don't need to like read locations twice within a single system. I do need read and write across multiple systems. So looking at this, I need to be able to arbitrarily read all the locations or write all the locations or read the velocities or read and write the locations and velocities. So whatever system we have has to handle that, both of that. So if we now go down to how we're going to store this in like all the entity data. So the entity data will be some kind of probably a hash map for this, because that will allow us to have something like, okay, we have the locations, we have these velocities, we have these accelerations, we have any other number of components that we want to add in. Okay, and then we're gonna want a vector of this like component. Now, if we need to arbitrarily write and read to these, I think like a problem that we're going to run into, I believe, is if I want read to locations and write to velocities, I need a mutable reference to world and an immutable reference to world, which is not going to work. I could just pass the entire world in, and then the system can query, but that's kind of like defeating the entire point of having a helper system. So I need to be able to somehow get multiple of these. I need to be able to pass in world as just immutable, so I can pass in each of these vectors multiple times, but then be able to get them mutably internally if I need to. Internal mutability is handled through only a couple different things. We have, and it's also going to depend upon if we're doing single threaded or multi-threaded. For this simulation, I'm going to go for a single threaded. We can potentially update this for multi-threaded if I want to. So what are my choices? We have cells and RefCells. So we can put a cell or RefCell, around this vec, and they both claim to offer interior mutability in Rust, which is a very interesting concept. Basically, the idea is I can just have a reference to this vector, but I can still mutate it. The way that cells work is they provide any number of clones as a reading. So like getting immutably is really just getting a clone of the thing. But getting mutably is a single mutable reference. Well, we see that we only need a single mutable reference of each specific thing. So that's fine. I don't need to like, that a cell could work for that. A clone, however, that would mean that for all the reads, I'm getting a clone of velocities, a clone of locations, a clone of, the accelerations maybe. That's pretty memory intensive because it actually has to clone all these. If we have a ton of these on the screen, that means every single frame I'm cloning, well, not even every single frame and every single system, I'm cloning multiple things. It's not too terrible if there's not very many of these, but this isn't very good. I don't think cell is the way we want to go. So I'm gonna say no, we can't do cell. It's too expensive for us. The way that RefCell works is we can get any number of references to the data for reading. but only one reference to the data for writing at a time. So, okay, if I put the ref cell around the entire object, I can only get like one reference, like many readable, entity data, but only one writing, which means I couldn't read and write to velocities and locations. Okay, so it can't go out here. It's gonna have to go somewhere on this side of the hash map. If I put it here, then I can get, it's an individual unique ref cell for this vector. So I would be able to get the velocities and I can just get a reference to it. Okay, that's fine, that seems to work. Or I can get a mutable reference to it. That could work as well, because I can then write to it. And RefCell allows us, if I have, and this is where RefCell gets very interesting. If I have, let's see, how do I always like, there, okay, so if I have a, let's say like velocities, I can borrow mute this, and suddenly I have a mutable reference to the contained data, which is really cool. That's what RefCell gives us. So I think RefCell is the way we want to go. So RefCell is good. We can put the RefCell in here or out here. So we can have like a vector of RefCell component or a RefCell of vector component. In this case, if we want to be able to get some of the components as read-only and some of them as mutable, then we could put the ref cell here, and that's where we would want to go. Otherwise, we want to put the ref cell here, and we just get the entire vector. It's readable or writable, and that's all that really matters. In this case, for like ECS systems, I'm looking at like vertical slices here. So I want the entire velocities as writable. That would be up here. I want the entire locations as writable. I want the entire accelerations as readable, for example. So that means I want a ref cell with a vector in it with component. Okay, and then finally, to store that in, and I'm not completely sure it's absolutely necessary, but it does seem to be like just used everywhere where you use ref cell. Oftentimes you throw it into an RC, which is a reference counting. It's a reference counting container. And we can throw the ref cell in. It forces us to only get references. But remember, only getting references isn't a problem, because I can just borrow mute from a reference and get writable data from it. So that still works. So I got all this. I watched John Hu's or John Gingset's, I probably butchered his name, his talk on interior mutability, which he did as a live stream here on Twitch. And he's actually a member of the Rustaceans team, right here. So if any of you are interested in following him, I would highly recommend. He streams every once in a while, and then talks about all sorts of interesting, deep level things in Rust. Okay, so for me now, what I want to do is sort of like redo my world here and like figure this out. So first thing I want to do is I want to rename this, because like data wasn't exactly right, but the entity, like the actual entity data is like what we're caring about here. And to be consistent, I'll do like that, entity data. And go ahead and refactor for me. Thank you, Rust Analyzer, for doing that for me for free. And I kind of want to just reset this. Now I have all this stuff in GitHub. So it's like, if I want to go and refresh it and like re-see it, it'll be fine. Now, everything's going to be really upset at me for a little bit of time, and that's going to be fine. Let's not worry about it too much. So we're going to have a pub struct entity data. And then we know that we're going to have, a clean slate. Epic Blarg, hello. Exactly. So we're going to have all the entity data. Well, what is the entity data? If we look at this, they're all the components that make up an entity. So that's what I'm going to call this, the components. And this is going to be a hash map. And I'm going to have a string. So that way our users, who is me, can say, okay, I want locations. Now I could create an enum to be here. However, that's just a little bit too constraining for me. It would means I have to update this every time I come up with a new type of component. And I think that I want to leave that up to like the flocking rust essentially, or asteroids, or breakout, or pitfall, or whatever game I'm making. Like that's what can do it. Now on the right hand side of these, we need our components. So we're gonna do a component. I may like rewrite a little bit about components too, because I've come up with some ideas for how to make that nicer, and also the resources of how to maybe do that as well. But we're gonna start here. Okay, so we have a hash map of string and component, and that's pretty much it that we have here. So let's go ahead and we'll derive defaults, and we'll impl entity data, hub function new, and we're going to create a new self. So we'll just do that for right now. Okay, so what are the different things that we need to do? We need to be able to insert into the entity. Okay, so that's important. So pub function insert mutable self. We also need the name of what we're coming in. So this is going to be the name, which is a string slice, and the component that's being added. And let's say we don't necessarily take anything in. What else do we need to do here? Let's just like create the signatures first. So we have insert, where we add a component in. We also, so that will allow us to add locations, add velocities, add accelerations for each of these, these birds. We also need to be able to query for them. That's going to be really important for us. We need to be able to get these velocities, get these locations. Now, what we just realized is we can't just do them from component here, because we need to do this entire VC RefCell vec component. So let's actually change this here. So we're going to have an RC, which for some reason Rust Analyzer can't find RC. So fine, use standard RC. So RC, then we're going to have the RefCell, and inside of that we're going to have our component. Okay, so now it's going to be a lot easier. So if we're going to query, and here's where it gets interesting. We don't ever have to query mutably for this, because it's all potentially mutable due to that RefCell. So I never need a query mute. So we're going to have a query. We can even just have this like that. This is pretty crazy. We don't even need the mute self here. We could just have a reference to self, and we're going to query for the name. Now what we're going to return is a pretty ugly type here. So I actually want to create this as a type here. So pub type. I'm going to make this public so it can be shared around. So this is going to be a query component or a component query. Or yeah, it's probably like, or it could be components. Could be components. And what is this going to be? Well, we kind of know what this is. It's going to be an RC with a RefCell with a component in it. That's what this is. There might be more to this. We'll have to figure that out. Okay, so we're going to return in here just a reference to a component. And that's it. I'm going to put a to-do in here so it doesn't yell at us too much yet. So we have the ability to insert and we have the ability to query. At this point in time, I think this is all we need for flocking simulator. If I was doing something like asteroids, let's say, well, we have a bunch of asteroids moving around the screen. Let's see. Tangent interior mutability could be read as roughly immutable, but mutable on demand. Yeah, okay, I could see that. That makes sense. I think like the biggest thing is wrapping the head around the idea of interior mutability in a language that prides itself on preventing problems, and then on the surface it feels like, what is going on here? But then when we get deeper down into it, it's more of, well, okay, if you trust the team to write a compiler that can have these safety restrictions, can we also trust the team to have runtime safety restrictions at the same time? If the answer is yes, then this is perfectly fine. You know, we're happy to use these official systems in place, these official containers, data structures that will protect us. But if the answer is no, and you're only willing to have compiler restrictions like compiler safety, then this is a no-go, and this isn't possible. So I would say, look, we trust the Rust team already. We should trust them more here. Or trust them the same amount here. I know. And I think I sort of got it, but also like hadn't looked deeply enough into it to understand what was going on. And I think I was just basically getting to the point where I was just sort of like flailing, like, oh, let me just try, you know, throw a dart at that random thing, and we're trying. And I'm not even hitting the board. But it's hard to tell. So like taking a step back, digging in a little bit deeper, understanding the underlying components, doing a little bit of research allows me to take the time to be able to create something like this. Which is really helpful, just drawing something like that out. And notice it doesn't take like forever to be able to do this. Like it just took half a day, like flailing in the morning, and then got it by night. So it's also like not too terrible, mind-wise, you know, mental-wise. Okay, so if we have this now, before I like implement this with the world, so I'm gonna come here. We're gonna make this all work. So I'm gonna go ahead. We have you working there. I'm gonna replace you with entity. Data is. So actually, we're gonna make you the components. Is that right? Or should we? Yeah, we should just do entity data. Entity data is the entity data. And to do, okay, so we're gonna place you. We're gonna have you be the entity data. And you are suddenly the entity data new. We're fine there. And then here we just have, okay, so your self dot entity data insert. You're fine with the with component. The spawn entity is still fine. The queries though, this is where things are going to get a little bit not right. So I'm just not going to do that right now. And insert and get resources. I'm actually probably going to change how that works too. So let's go ahead and just not even have resources yet. We're just gonna have a world. Remove all of you. Remove you. Remove you. All we have is a world with our entity data. We can spawn an entity that inserts components. And there we go. Okay. Create. And then I'm just gonna get rid of our tests temporarily. Because another thing I was realizing, and my wife was reminding me of this. She's a software engineer too, so she was watching some of my stuff and it's like, yeah, you should probably just skip the test-driven development until after you understand it a lot more. All right, let's not. You don't need cell there. What am I doing? Okay, so now inserting. Let's get this going. I want to do a self.components.entry. We're gonna give it the name. Now I noticed that this name, it needs to be to owned. So we're gonna to owned it. And then we're gonna do an or default. Or default, where it's gonna look here. And actually I'm missing this. This is RC RefCell with inside of this is a vec of component. You're a vec of components in here. Almost missed that. Okay. So can you do that? That's a good question. We're gonna do let our components equals, and we see here that we have a mutable reference to this RC. Well, yeah, it's gonna be a little bit interesting because I need it to be mutable in order to create the new RC RefCell vec, because that's what this to default or default is doing. It's saying, hey, if this line doesn't exist, if we don't have a locations, but we try to add it, go ahead and create the RC, the RefCell, and the vec. And it's just all gonna be empty. Okay, now this is saying, hey, you're returning this. It's not what I wanna do. All right, I put a semicolon on it, so it's happier now. Components is this mutable reference to it. We are gonna have to mutate it, so that's gonna be fine. So what I need to do is I need to get inside of all of this to be able to get at this vector and then push in this component. So how do I do that? Well, we have this RC, but I can almost ignore it and just go straight to the ref cell. And the reason for that is auto, not destructuring, it's dereferencing, auto dereferencing. Whenever I do anything to this, it's gonna try to deref automatically inside just to get to the ref cell. So I can just call the ref cell methods and we're fine. So what I want to do is borrow the ref cell mutably, and that will give me this vec. So let's do that. So let's do let borrowed components equals components dot borrow mute. And that gives us a ref mute with a vector of component. But at this point in time, it's the exact same thing as we had with the RC. I can go ahead and pretend that I have the vector, and it's gonna dereference into that vector. So now I can do, and I do have to tell the compiler that this is mutable. And this suddenly doesn't need to be mutable because I'm treating it as if it's just a reference. Then I'm going to push this component in. So we're going to do a borrowed components that push and add the component. And this is happy. Like it's not yelling at us. Now, something that I could do here, I believe that I could just borrow it directly off of here. So borrow mute off of there, and then I can skip this line completely. And that allows me to push directly in. I could even borrow mute and then straight that push component directly in here. And that just makes it a single line. I don't even need this. And that inserts in. Just one line, we entry this or the default, then borrow mute that, and then push it. And push our component in, and we're fine. We've got that in there. Okay, perfect. Now let's figure out about our query. So I only need a reference query. That's fine. And right now we're just gonna do a single query and not like trying to query multiple things. That's gonna be fine. Maybe to make that absolutely clear, we're just gonna do a query 1. Something else that we're gonna do is, and maybe this one needs a little bit of documentation, query for a single vector of components in the entity data hash map. If we cannot find the components, then we will panic. I've noticed that in a lot of Rust libraries or a lot of Rust APIs, a common practice is to do something like query 1 panics if it can't find a thing. Try query 1 will return an option, so if it couldn't find it, then you can handle it up. I don't plan on requiring the try query 1 unless like I'm going to be dynamically adding things that I don't know about. I'm not creating this library to be really used by anybody else. Like obviously, if any of you want to try it out, you're very welcome to. But really, this is going to help me in my games and my simulations to be faster and like hopefully a little bit better. So then we will panic. So, okay, so query 1, how do we query for this? We're gonna return a self.entity self.components. Just get, we don't need to get mute. The key is the name, and it's this option. So let's just unwrap, and that's gonna be the crashing, the panicking if we don't find it. And that's it. That's all we do. Because we're gonna get the thing, and it's either gonna be one of these or a panic. That's it. I don't want to borrow a mute, or at this point in time, unless I was to start creating like a query 1 mute and a query, and then it would be sort of like readable and writable. I could potentially do that. I'm not going to worry about that right now. We're just going to return these components, and then we'll just have to be aware that it's a ref cell that we can borrow mute at the use time. So let's go ahead and head on up to mod, and we're going to, we already have our insert. Let's just do our query 1 here. So I'm going to do our pub function, query 1, a reference to self, because once again, I don't need mutable reference in this case, and the name. And we're going to return a reference to component. I'm going to do self.entityData.query1 and pass it in the name, and sort of like just forwarding on through that. Okay, so at this point in time, it allows us to head into our flocking Rust, and we have a little bit of work to do, sort of like to fix this up. So let's go ahead and set that up. We have our world, so we have our background color, which these can all be systems here. This can be a system, system. This can be a resource. This can be a resource. So background color can be a resource. A mutable world. Let's go back to storing our bird mesh as a mesh. Because I'm not going to do this as part of the world yet. I'm going to redo that section too with all that we know about the RC and RefCell, or cell, depending upon what we need. We haven't really thought about that too in depth, so it'll be good to like think about that uniquely when we get there. Okay, so we have our bird mesh. We created that here. We have our world. We're going to spawn entity. These are going to be our two birds, as it were. So we have a with component location, and we component create a vector here. I'm gonna probably fix the components and make them a little bit nicer in a little bit, but let's not worry about that right this second. So we create these two components. We do the same thing with another entity with two components. Then we world insert resource. Let's just go ahead and not do that. Okay, so self, we have our background color, our world. Now this entire thing, yeah, no, you are just a world. Our world, and then also our bird mesh. Okay, so that makes us happy. Now we're gonna come down here. We were running into all this trouble trying to figure out how to do resources, but we know how to do those now. So we don't need to do any of this kind of craziness. Let's skip this. We're not gonna do the update for right now. We're just gonna do the system for drawing the birds. So we're gonna pass in the bird mesh, a reference to self.birdmesh, and a reference to self.world. We just need a reference. We don't need a mutable reference. Okay, so go to the bird mesh, the draw bird system. All right, so we have the context. We also need the mesh, which is going to be our a reference to a mesh. That's fine. And then the world is going to be a reference to a world. All right. Don't need to do this. Don't need to do this. Don't need to do this entire fun thing. Don't need to do this. In fact, you know what? Screw it. We're starting over with this. What do we need to draw the birds out? We need the locations. That's it. We need the locations and we need the meshes. Oh, hello. How are you doing, Zilby? You were happy with hello, and now you want to play. Okay, I don't have a toy down here. I need to buy a new toy. We need your wires not wrapped around your feet. Okay, go down there. Okay, so I need the locations. So let's query for the locations. So let locations is going to be equal to our world.query1. Location is what we care about. We could throw this into an enum. So we can throw that into an enum and that would work for us. Okay. In fact, we can make the location, like the world, take like a T, essentially, a generic for the key. That might be really good. Okay, so that gives us this reference to an RC ref cell. Okay, so we know we can skip directly through the RC to the ref cell, and we know we only need readable. So let's just borrow this. And that gives us a ref to a vec component. We now know that we just have access to the locations. So that's cool. We just have that. We can now loop through all of these locations, and we already have our yeah, we're good at that point in time. We have our meshes also. Oh, Zilby, you walked over and just want to play? So sorry, I don't have a toy for you. Okay, so we're gonna loop through all of our locations and then draw. So the easiest way to do this is a good old, well, just standard loops. We're gonna do locations dot, we want to iter, then we can try for each. I'm gonna get a location. Okay, that gives us, we see this component here. We're gonna run into a little bit of trouble pretty quickly here because we need to be able to essentially cast this location into the appropriate thing. So I was thinking about like our first attempts of storing the data was using dynamic dispatch and the any trait. And any trait had a really cool method on it called downcast, which will allow us to like turn it into whatever type we knew that it was, and it would crash or return an option essentially if it wasn't that. Let's do that. Let's actually write that. So we're gonna go to components in here. Oh, unable to open you. I need to actually go and tell you where it is. It's you. So I want, so this entire like function for like get rid of you too. We'll bring that back later, maybe. Okay, so we have this vector2. I'm actually thinking, let's just do this now. I don't need to do vector2. It wasn't really working the way I wanted it to. Like maybe the vector2 could help us out in the future. Maybe. We can try it again. So we have this component, which is the vector2, which really has this vector2 in here. So this is fine. So create a vector2, takes in this x and y, and returns a self vector2. Okay, so this is all fine. But then I want to be a get vector2. So I'm actually going to call this cast vector2. Change you to be that also. I'm not going to return an option. Once again, I'm just going to crash if it's not the thing that we want it to be. So in this case, you're going to be a reference to a vector2. So this is the next thing is like, well, how do I want, like, how do I need to do this? Do I need to like have like an ref cell in here in case we need to like update you? Because that's going to be important. Is I need to be able to like potentially update internally in here. So that's going to be interesting as well. So I probably do need like to wrap this in a ref cell so I can get the internal mutability of this. Because then I just need a reference to self. I don't need mutable. So that's really important. The world is immutable. This has to be immutable too. Okay, so that being said, I might be able to update it, but if I cast to it, I might be able to like, I could just recreate it too. That's certainly a possibility. Let's not worry about that right this second. We're gonna come back to it. So right now, let's just say we're gonna return a reference to a vector2 of f32. So if let self vector2 is this vector2 equals self, we return the vector2. Otherwise, we panic. And we'll just directly panic with a message. Tried to cast component to something not a vector2. And that allows me to sort of like extract this out. All right, so in our library, when we're creating this new, yeah, I just create, these are like that now. Draw bird system, takes 2 arguments, but 3 arguments were supplied. Wait a second, I thought I updated you. Oh, did I not save? I don't think I saved. That's right. Update locations. Let's go ahead and this is just a big mess. So goodbye. Update locations, you go away, and you go away. All right, so all we're caring about here is this draw birds. So we have our location. We need to now cast this out. So we're gonna say we want a that location. I can just shadow this equals location dot. We can even say that this is really just the component. Now we want to cast do not know how to do that. Cast vector 2. What are you upset about? Let's see. We have a ref vector, so we borrow, which gives us a ref. We have this component. Oh, you're just upset because we're not returning something like, okay. Okay, so then you try for each. Not implemented, so we also need to return like okay here too. Okay, cannot find value location, right, because you're a component. And here we go. Now we have, it's this matrix thing, which is actually the type, the like custom type that's created for what a vector 2 is. So now we have this vector 2. Now, if I wrap this in like a ref cell, we'd be able to get that interior mutability to update it, which might be really important later. And then we have to like borrow it, and that'd be fine. In fact, it might be a good idea for us to like try to do that now. Okay, so then we have our let location. Let's go ahead and do our draw here. So we're gonna do a graphics draw, add in the context, add in a referent, add in the mesh, and then add in the draw param default.dest, and it'll be our location.x or location.y, and we're going to return this, so that'll be fine. Now, what are you upset about? This can be turned here like that, and that goes out as the game result. Okay, so that's fine. This is so much easier to look at, which is just really nice. Now, I believe this will work. And we should get our static birds just sort of sitting there and not moving. There we go. So that's what we were expecting to get. And the queries are just so much nicer looking. Now, if I wanted interior immutability for the component, that's going to be our update. So we need a new system in here. So a new file. This is going to be like update locations. RS. So let's figure this one out, because this is going to be like our bigger problem. we're close to it, but we're not exactly there. So this is going to be a pub function update locations system. We know we're going to take in a reference to the world, and that's it. Like, that's all we're going to care about here. And I don't even know if we're going to return anything. We know we're going to need to get the locations need to be mutable and the velocities need to be readable, and that's it. So let locations equals world dot. Oh, I need to tell you what type you are. That would be helpful. What am I doing? World is a reference to a world. There it goes. Okay, so we have world dot query one, and we need a location. That gives us our ref cell. Let's go ahead and borrow mute this. Okay, that's ref mute of the vector. So we're good to go there. Now let our velocities equal to world.query1 velocity. This can just be a standard borrow because we don't need to update it. And we'll notice here that, okay, it's just a ref, but this is fine because each of those ref cells around each of the individual vectors. And as long as we're getting the world just reference, we're okay here. We're not okay here. We're going to run into a problem very shortly. Okay, so we need to loop through all the locations and the velocities and update the locations. So let's go ahead and we'll do the for each through the locations. So we're going to do locations dot iter. We're going to enumerate so we can get the and then for each. This will now get us the index, and we're also going to get a location, or rather a component. So we can just call this like a location component, might be a little bit easier. And then from here, we can now like get the velocity out specifically for it, but we probably want to like actually downcast that location. You see the problem here? Our component, we don't have interior mutability to the component itself. So when I downcast this, so when I say location, it's equal to location component dot cast vector 2, it's just a reference. I don't have the ability to write to it, nor will I ever have the ability to write to it. Now getting the velocity is going to be fine too. So do velocity is equal to, all right, so velocities of index, that gives us the component, and then we're going to get a cast vector 2, and well, this is fine actually. We don't care about writing to this. We do care about writing to this one. So suddenly now when I try to do location.x plus equals to velocity.x, location.y plus equals to velocity.y, you should yell at me saying, hey, I can't borrow this as mutable. And if I try to say, well, what if I just make you mutable? This should also yell at me saying, hey, it's behind a reference. I can't do this. I can't get it out. Now, you know, what if I tried to return a mutable reference as like a cast vector too? Like what if I went back here? This shouldn't work. Let's see, where do I put this? Mod. What if I try to make you a mutable vector 2 here, and you become mutable like that? So what happens? in our update locations. Cannot borrow location component as mutable. Oh wait, I think, was I supposed to? Yeah, so borrow mute for the locations. So yeah, I can't borrow it because location component, no matter what I do, well, I can iter mute this. It's like it claims that I can do this. Now velocities is yelling at me. Cannot borrow this as deref, as mutable. I don't want to. Locations. Okay, so I need to like mute this, tell it that I could. I don't want to borrow this as mutable anymore though. It's like, why are you yelling at me? So let's take a look at this. We're casting, well, that's because cast vector 2. So really I would want to like cast vector 2 mute to like be very specific about this. So it's actually just say we have this one that returns a non-mute, and we do this again to do mute. Like that. So you claim I don't need you to be mutable. Okay, so we have a mutable reference to the location. If immutable, well, actually, will this work? Will this be fine? Because it's in the ref cell and I could just do this. Let's find out. If I try to run the update location system now in the main library, that's going to be in this update. Before this, okay, we're going to say update systems locations, and it's going to be referenced to self dot. If we do this and we run you, what happens? Okay, I actually don't need to return another ref cell, or I was thinking I might need to, but because the ref cell over the component, everything is interior mutability, even sub things. So like not just the vector, but the components inside the vector too, which is really cool. So now I have moving components, and if we take a look at our system, it's not nearly as complicated as I was starting to make it out to be. It just is going to be this, I'm casting it into whatever I want it to be. Either it's casting mute or casting read. And that makes it so much easier to do. Now, one thing I wanted to do, and one thing that the vector 2 is really going to help me out, otherwise I don't want to use a vector 2, is could I do location plus equals to velocity? Could I just do that? And the problem is it's telling me I can't. Cannot be applied to type of reference, mutable reference to you. Do I need to like do anything weird? Like, no, I don't need to like make you mutable, do I? No, so I'm not getting like a vector 2. Like I'm not actually getting the vector 2 back out of it. So because of this makes me feel like I don't want to use NAlgebra as vectors. If I'm not going to get the benefit of the vector method, then why bother? I can have to rewrite all those methods that are on vector 2 anyways. So I want to make this work. Like I want to make this work if I can. So instead, let's come back to components here. We're going to create a new component, and I'm going to call this a point. We can just call this like a point 2, .rs. A pub mod point 2. And we're going to say you are a point 2 point 2. That's what. Like I can even just call this a point, maybe. This'll be good enough. Go ahead. So we have a point, point. Okay, so self point. Give me a point new. Well, you don't exist yet. We'll make you exist. Don't do that. Okay, so then self vector 2. So every time we see a vector 2, we want to turn you into a point. And that's going to be fine. I don't need to tell you that you're an F32. We're just going to say all the points are F32s. Yay! Okay. I think that was the last there. Let's go ahead and add like a new in here, or actually make the thing real. So we're going to do a pub struct point. This is going to have an X, which is an F32, and a Y, which is F32. We're going to default this. We're gonna have an X and a which is an F32, and a Y, which is an F32. We're gonna return a new self. So it's me self, X and Y. Okay, so that's gonna make things a lot easier up here. So we have this point. We need to pull in. Why can't you find it? Oh, I don't want to pull in an algebra point. I want to pull in this point. Import point from you. Okay, so if I want copy, I don't need all of this stuff. So I'm just gonna remove you. Okay, so we could create like a new point here. It actually feels like this makes more sense for me to just have a component and we just throw in the point, because it's actually gonna be easy. Okay, so like we're gonna cast to a point. So it's gonna be a point. And we're gonna cast point mute. Okay, so that's gonna be easier there. And then what do you care about? We need you to be public. I don't feel like necessarily doing getters and setters for this. And now, okay, so here. We have to update this. So component, this is gonna be a little bit easier. We're gonna do component, point, point new of like, let's say 50.0. 50.0. And then our velocity is going to be the same exact thing. So we're going to update you to be a point. And then inside of here, we're going to have these be point new with like whatever, right? So let's just take we'll give the velocities the same velocity. So you're going to be like, I don't know, 1.0, 1.0. So you'll be going down in that direction still. And for this one, let's do like 75.0, 150.0. Just something different. Okay. So it gives us that. So we're happy there. What else are we yelling about in this file? Oh, semicolon U, semicolon U. With components. I'm missing a parentheses. Okay, so we're happy. Okay, we're happy here in this file. Draw birds. Okay, so this is going to be just a cast point. It doesn't need to be mutable, so that gives us back this reference to this point, and we're good to go. So this can be location.x, location.y. Look at this. We have like to this like array. I can actually put in our point. Let's see if we can add in a method to make that helpful a little bit. So pump function to array, and I think it's actually into array. We're gonna do a reference to self, return a, all right, so it's gonna be an array of F32 2. And we're gonna return an array of X and Y. That's gonna be it. Well, self.x would be helpful. Ooh, wrong self conv. What are you upset about? Methods called into usually take self by value. Oh, yeah, okay. I don't want to do into then. What's the name for it? Naming is hard. I don't want to turn it into something. I do want to turn it like as something, or like convert to. What if I do like to array? Will you be? Yeah, okay, you're less upset. So can I come back to draw birds? And now I just want to do location dot to array, like that. I can. Okay, so this is going to be so much better, because when we get to update locations now, you're going to be, we want to cast point mute, and we want you to be cast point. And so if I want this like plus equals, this is going to yell at us saying, hey, we can't do this. Can I use plus equals on here? It's add a sign is the way this works. So I can come to our point and we can impl add a sign for point. Implement missing members. Okay, so we have the right-hand side, which is some other point. It has to be the same type as this, so self is fine. And then we're gonna update this. So what is this gonna be? We're gonna have to say self dot x is plus equals to our right hand side dot x. Self.y is plus equals to rhs.y. And that's it. That's all we need to do here. So then back to you. Are you gonna work? You're a mutable reference. So I should be able to do you, and you're this like point. I shouldn't need to like dereference you, right? I should be able to like just get you. Cannot use untype type mutable point. Cannot be applied to type mutable reference. Maybe I need to like rerun you. Okay, so cannot use plus equals on type. So mutable reference to a component point. Well, are you gonna give me more information why? No? Why can I not? I've implemented add a sign. So that should work for it. Like normally. Oh, okay, hold on. This is self. Can I just say like you're a reference to self? Do I need to clone this right-hand side? It's like, do I need to somehow clone you? I guess I don't know which one it's yelling at. Is it upset about this side or this side? I don't know. Because I can get the X out of the velocity. Like if I do it manually, it's fine. Everything's fine. What I can't do, it seems, is do this add a sign out of here, which I'm a little bit sad about. Like we have this mutable reference to self. Okay, that makes sense. We have the right-hand side, which is this owned by self. Okay, so let's say I don't do add a sign. Can I do this manually? Can we say pub function add? We'll do immutable self, and we'll have like the other point. We can just do the other, which is a reference to a point. We don't return anything. We're going to say self.x is plus equals to other.x. Self.y is plus equals to other.y. Okay, so back to update locations. I want to do location dot add velocity. Yeah, this works. So I can't use the trait on that. And I don't really understand why. So if any of you know the reason why I can't use the traits on this, like maybe I'm like somehow getting the wrong points. Even if I try to cast this to a point mute, it doesn't work also for some reason. If I clone it, it doesn't work. I don't understand. But if I do this and we run this, we should be able to be back exactly where we were before, which is we have our moving birds, our flocking simulation is running, and everything is so much cleaner and easier to work with. So we'll be able to now update. So like coming up, we'll be updating our resources to be able to add resources in. We'll be able to maybe even change the keys, so we don't have to remember and type location and velocity and have these be magic, which will help out a little bit. But that is going to have to be tomorrow. So I'm going to go ahead and close all these down, and I want to save this all up to GitHub before I forget. So in VB ECS, we have, finally, we are updating the, well, I guess like correctly getting the, what is it? Like we're correctly getting the components out of the world. And then on the flocking, well, let's push this up too. On the flocking side, we are updating the, well, I guess like cleaned up the systems for new, better world. No. Okay, yeah, you know that just happens to be that way. My VS Code, I have a line highlighter, so you can do bang line, and it will like highlight whatever line you want to. So like bang line 3, bang line 95. So you can say like, ooh, you screwed up in this line, or what does this line do? However, of course, I just turned off VS Code, so that's all gone. All right, so tomorrow the plan is gonna be 7 a.m. Mountain Time. I'll be back. And I'm going to be working on just more improvements to this. Probably resources is going to be next, because that's like the next biggest thing before I can start creating all those other systems in order to like make the flocking simulation happen. So I'm going to go ahead and add in a